to look at hypothesis testing for two proportions. Time magazine reported the result of a telephone poll of 800 adults, Americans, both smokers and non-smokers. The question posed of the Americans who were surveyed was, should the federal tax on cigarettes be raised to pay for health care reform? Of the 605 non-smokers who responded, 351 said yes, and of the 195 smokers who responded, 41 said yes. Is there sufficient evidence at the alpha equals 0.05 level to conclude that the two populations differ significantly with respect to their opinions? So when we are doing hypothesis tests, in addition to the normal steps, we want to make sure we define what each of our proportions represent. So again, you don't have to use the subscript 1 and 2. You could use N for the proportion of non-smokers, and then S for proportion of smokers, just to keep it straight. But here you can see I kept it at 1 and 2, and I wrote out what each of those proportions represents. So P1 is the proportion of all non-smokers who think the federal tax should be raised, and then P2 is the same thing except it's smokers. And when we're doing our hypotheses, we want to keep in mind that the null in this case would say that P1 equals P2, that there is no difference between the proportion of smokers in both groups who think the tax should be raised. Another way you can write that is just P1 minus P2 equals 0. Okay, but the choice is yours, so whichever way makes more sense to you, but you do want to be familiar with both ways. The alternative in this case is going to be P1 does not equal P2. And I know that because the question we're looking at is we want to see whether the two populations differ significantly. So that just means, are they not equal? And then of course you can always write it as P1 minus P2 does not equal 0. So that means there is a difference. I want to check my steps, but usually I do that after I write down my calculations here. So to check your conditions and your assumptions, remember you want to make sure both groups are independent. So we can assume that yes, they are, because a group of non-smokers shouldn't affect a group of smokers. There might be difference, there might be like some instances where if it's from the same household, there could be a non-smoker and a smoker living together, but we're going to assume that their choices are going to be independent of each other. The second thing we want to check is randomization. So the problem itself does not say that they were randomly chosen, but both groups should be representative of both populations. Okay, we know that 605 non-smokers and 195 smokers are less than 10% of the population of all smokers and non-smokers. And we also know that if we were to calculate success failure, that if I did 605 times, or 351 is greater than or equal to 10, right? So 351 adults, and then if I subtract 605 minus 351, obviously that's still greater than or equal to 10. 41 is greater than or equal to 10, and 195 minus 41 is greater than or equal to 10. So I know that all the conditions hold, so therefore the normal model can be applied. Okay, so check the conditions, right? So conditions, it's usually step 3, but we'll put it here under step 2. As long as we do the steps, it doesn't matter. So conditions are satisfied. So it's okay to use the normal model. All right. So what are some things I need to find here? Well, I need to know the sample proportion of non-smokers who think you should raise the tax. And the problem told us 351 out of the 605 said yes. So to find P hat 1, I'm going to divide 351 by the sample size, which is 605. And when you do that, you get 0.58. And then P hat 2 is the same, except it's for the smokers. So that was 41 out of 195. And that equals 0.21. I need to find the standard error of p hat 1 minus p hat 2. So remember, for that, what I'm going to do is I'm going to take my p hat 1, which was 58%, times 1 minus that, which is 0.42, and divide that by the total sample size for non-smokers, plus the proportion of smokers who think the tax should be raised times 1 minus that, which is 0.79. And then I'm going to divide by the sample size for the smokers. Be really careful typing this in, but when you do, you should end up with 0.035 for your standard error. So now I want to find z. Remember, z is just the value minus the mean divided by the standard error. So the value would be my p hats minus the mean divided by the standard error. So p hat 1 minus p hat 2 means I just need to take these and subtract them. Minus p. So p is always with the hypothesis because that's about your population, it's your claim. And there, p should be 0, right? Because we're saying there is no difference between the two populations. And then we're going to divide by the standard error, which we just found to be 0.035. When I do that, I end up with 10.57. So that's a really long, far, that just means that those are really far away from the mean, right? It's 10.57 standard deviations from the mean. So you can probably calculate already what the p-value is. But in step number 4, I am going to draw my picture. Okay, so we are allowed to use the normal model because our conditions were satisfied. The mean is 0, right? And again, I get that from the hypothesis, the null hypothesis. And we're going to go 3 standard deviations in either way. If you wanted to, you could add 0.035 to each of these, but I'm not going to bother doing that. My standard deviation is 10.57, so that's basically off the, viewing space there that you can see. And then we would have negative 10.57 since we're doing a two-tailed test. And we would shade to the right and to the left. The further we go out towards the tails, the smaller the probability gets. It's basically 0. So I really don't even need to calculate anything here. But if you wanted to, you could. If you go into your calculator and you go to stat, go to second vars rather, and we're going to do normal CDF. And we have an add here, which I think I can close. All right, so normal CDF. Let's say our lower bound is going to be the 10.57. That means our upper bound is going to be 100. And then the mean is 0, standard deviation 1. And then hit enter. And it's telling us that it's basically a 0. So the probability that z does not equal 10.57, which was our z-score, is basically just 2 times the probability that z is greater than 10.57. Okay, because again, we're looking at twice the area since it's two-tailed. And here we ended up with 0, which makes sense. Okay, so what does that mean for steps 5 and 6? Well, 0 is less than our alpha level, which was 5%. So we're going to reject the null. So since 0 is less than 0.05, we're going to reject the null. Okay, so what does that mean? When we reject the null, we would say there is strong evidence to suggest what? Well, we were trying to prove, we were trying to look to see if the two populations differed significantly, so they clearly do. So there is strong evidence to suggest the two populations differ significantly in their opinion. Okay, please stay tuned for the next video where we discuss and look at confidence intervals.